Hello and welcome to the Unreal Numbers. Today we are given a permutation problem. So the problem says that we are given a grid which is actually a map of a city. And those horizontal and vertical lines represent the roads or streets of this city. Let's say we want to move from this yellow point to the red point and we are only allowed to take horizontal or vertical steps. The question is, how many shortest paths are there from the yellow point to the red point? Now let us try to understand what is a shortest path. So a path from this yellow point to red point can be like this. Here, is this path a shortest path? It's not, because you may notice that I am taking a few left or down step while I'm moving. But if you look at the position of the red point related to the yellow point, it's on the northeast direction. It's on the northeast direction, or we may say that up and right direction. So we are only allowed to take either up steps or right steps. Whenever we take any left or down steps, we make the path longer. So we can understand that any shortest path is combination of a few right and a few up steps. Now, how many shortest paths are there? To understand that, we need to understand the key concept, which is permutation with repetition. Let's say we are given three distinct objects, A, B, and C. We want to see how many different arrangements of this A, B, C are there, just like this. Let us assume three blank spaces, as we have to arrange three letters. So the first blank space, to fill up the first blank space, we actually have three options. It could be A or B or C. But as we use one of the options, we are left with only two options in the second place, and then only one option in the third place. So using the fundamental theorem of counting, we can say that the total number of arrangement is equal to 3 times 2 times 1, which is equal to 6, or we can think it as 3 factorial. And these are the all 6 possibilities, all 6 arrangements. So this is the fact that n distinct objects can be arranged in n factorial ways. Now let us make a little change to the question that we have asked. Let's say we are given three objects, but two of them are identical. How many arrangements are there? So let us first assume that we are given three different objects, one red A, one blue A, and a C. So they are all three different objects. So as usual, we will see these 6 options as we have seen before. But as soon as we get rid of the colors, if we think that both the A's are identical, we see that a few options are basically same, as we can see 2AAC, 2ACA, and 2CAA. So each of the options are repeating twice. Now why is that happening? Because these two A's are switching their positions, but we cannot understand that. That means the total number of arrangements, if they were all different, that should be 3 factorial. But as the A's are switching positions, that many times each option would repeat. So the total number of arrangements would be 3 factorial by 2 factorial. So in general, if we are given P identical objects, Q identical objects, and R identical objects, where P plus Q plus R is equal to N, then there are total n objects. If they were all different, the total number of arrangements should be n factorial. But as P objects will be switching their positions, and we will not be able to understand that, that is why each choice should repeat for P factorial times. So the n factorial should be divided by P factorial, and with the similar argument, it should be divided by Q factorial as well as with R factorial. Now let us go to the solution of the problem that we have started with. If we notice the grid properly, we may see that for any shortest paths, there are only 5 right steps and 3 up steps. So the number of right and number of up steps are limited. So NA shortest path is basically a combination of a few up steps and a few right steps. And the path changes for different arrangement of these U's and R's. Just like this. If we take a different arrangement now, we get a different shortest path. For another arrangement like this, we get this shortest path. So we can understand that each of the shortest paths are uniquely connected to one of these RU words. That means a word with 5 R's and 3 U's. So if we count the number of all such RU words or all arrangements of R's and U's, that will be exactly equal to the set of all shortest paths. Now we clearly know how to count number of all such RU arrangements. There are 8 different objects. If they were all different, there should be 8 objects. So for that we'll get a 8 factorial. But 5 R's are identical. For that we get divided by 5 factorial. And then for 3 U's we get divided by 3 factorial. So the actual answer is 8 factorial over 5 factorial into 3 factorial. Thank you for watching. Please stay tuned until we meet again.